Forecasting. So what does your local weatherman or the National Weather Service do to determine a forecast? Well, there are several steps involved. The first and most important step is collecting data. So here they're looking at, over the course of however many years they've been collecting data, things like temperature, pressure, humidity, cloud coverage, precipitation, wind. All of these things are collected. Then they look to see, well, based on our data, looking at the days that have had conditions similar to today, what happened? So when you hear a forecast say something like there is a 60% chance of rain, what that means is, historically, under the same conditions, 60% of the time it has rained. So it doesn't mean that there's, during the course of the day, 60% of your day is going to rain. There's no guarantee it's going to rain. 40% of the days with similar conditions did not rain. So unless there's a 100% chance, you still may or may not get what the weatherman is predicting. So that's based on all of this historical data. Then they use models, and we load the data into the models. And so the models basically take this historical information and look for trends. And then it also uses known scientific laws and combines all that together to figure out what places are going to get rain, based on the winds and the pressure and temperature and all of those things, and looks at the physics behind atmospheric phenomena to figure out what's going to happen. Well, then you see what happens. Add that to the data, and repeat. So it is a continuous process, looking to see what happens, is it right or is it wrong, and going back and continuing to tweak it. It's very much like the scientific method in that respect. Now, how accurate are forecasts? Short term are fairly accurate. Never perfect, but certainly pretty close. Long term, not so much. And the graph here is showing the accuracy for temperature forecasts from various weather services. And apparently AccuWeather goes all the way out to 2 weeks into the future. Nobody else seems to be willing to commit that far. But what you can see is it definitely gets worse the farther out you go. It looks like MSN weather is not very good. They are kind of the outliers in most of these data sets here. overall, National Weather Service, our red bars there, look pretty good. Unisys looks pretty good. And the others, I mean, they're all in the same ballpark and they're all using the same data, so you're not going to see a wide range of differences, other than the MSN weather. So don't get your weather from them. One of the things here in Tennessee that affects the accuracy is landscape. If you live in a place that's flat, easy to forecast. If there's mountains, it's harder. So I grew up right about there in northern Indiana. This whole part of our country is very flat. So I could see what the weather was doing over here, so in this case freezing rain. Watch the satellite loop to see how fast it's moving, and I could do a pretty good job of telling you when that was going to hit us, because there was nothing between us and them, and it was real easy to see how fast it was moving and whether it was headed for us or not. Here in East Tennessee, we've got all these mountains. Mountains divert weather systems. So there might be something coming straight for us, then the currents around the mountains could end up diverting it away. Or it could be coming up from the Gulf, hit those mountains and get diverted away. So it's a lot harder to tell around mountainous regions which way a system is going to move than it is out where it's nice and flat. And so, cut your weatherman a little slack here, because it's not easy when you've got interesting terrain between you and the fronts that are moving and trying to figure out for sure what they're going to do. So that's how a forecast is made and everything that goes into it.